Okay, so we're taking up Chapter 1 test. Question 16, they've given you the measurements of a triangle. They call the triangle XYZ. It says that side X is 19.1 meters. Side Y is 32.7. And side Z is 41.2. This is all the information they give you in the question. Then each of these questions ask you something different about the triangle. Very first question, A, says, suppose that one angle is obtuse. Which angle must it be? So what I'm going to do is I'm going to draw or sketch a quick diagram of our triangle. We don't know if it's a right angle triangle, so we're going to assume it's not. We're going to call the triangle XYZ. So this will be our side Z. X and Y, these are the angles. So side X was 19.1. I should switch that with Y actually. Just to make this to scale, we're going to switch X and Y. Side Y, side X. So we have 19.1. Side Y is 32.7. Side Z is 41.2. So looking at this triangle, the longest side I drew was 41.2. They said that one of the angles must be obtuse, okay? So if we're going to make an assumption of which one's obtuse, it would be opposite of what side of the triangle? The longest side. Since this is our longest side, we go on the assumption that that must be the obtuse angle. So our angle Z, or Z, is the obtuse angle. And that is, again, because it is opposite of the longest side of the triangle. Okay? Okay, B, determine the measure of the angle you identified in part A. Show your work. Is the angle obtuse? Okay, so we've already sketched out the triangle here. I need to find the measurement of the angle we pointed out, which is our angle Z. I have the measurements of 3 sides of the triangle. So of all the formulas I have on the right here, which formula am I going to be using to solve for angle Z? Anyone know? If I have 3 sides of the triangle, I'm trying to find an angle. Cosine law. Okay? That means we have C, A, and B, so we can rename this triangle like we said we would before. And we're going to be looking for the angle C from our formula. So I'm going to rename this triangle. Remember I told you when using cosine law, if we're going to rename it, we're always going to call side C the variable, or the side or angle we're looking for. So in this case, Z now becomes angle C. This is our side C. The A and B in that formula aren't as important. We're just going to arbitrarily put them. So we have side A, angle A, side B, angle B. Okay? So we know we're using our cosine law. So C squared. Side C is 41.2. So I'm going to start with 41.2 squared is equal to, side A is our 19.1, so 19.1 squared, plus side B is 32.7 squared. So again, guys, I'm using this formula here, our cosine law. Make sure you guys have all these formulas down. Then it says subtracted by 2 times side A again is 19.1. Side B is 32.7, and then cos, and I'm going to highlight this one in green, C or Z, that's the angle we're looking for. Now clearly I don't have enough room on the page I put it, so I'm going to go to a blank page now. I'm going to move that formula over. So what we're going to do is we're going to work out and evaluate all of our exponents to start. So 41.2 can't see from here. Squared gives us, okay? Then we're going to look for 19.1 squared. So 19.1 squared, 364.81. 364.81 plus 32.7 squared. 32.7 squared. 1,069.29. 0.29. Okay. We run out of room here, so I'm going to hide that. There we go. Then I'm going to equate what we have here. 2 times 19.1 times 37.2. I know that's really squished in there, okay? So we have 2 multiplied by 19.1 multiplied by 32.7. 1,249.14. Okay? So we keep that subtraction sign, we bring that down, and we have 1,249.14. We still have cos C here. Okay? Next step, what I'm going to do is I'm going to evaluate these two here, put them into a single number, and then I'm going to go over one part where many of you guys had made mistakes on the test. Okay? So we have 364.81 plus 1,069.29 equals 364.81 plus 1,069. Okay, 1,434.1 minus 1,249.14, and I'm just going to write this in black now. Now, this is where many of you guys made the mistake, okay? According to BEDMAS, this number here, our 1,249.14, is multiplied by cos C. Okay, so what that means is I cannot subtract these two numbers because we should be dealing with the multiplication here first. So instead what we're going to do is we're going to move this first number I've evaluated to the other side of the equation. When I move it over, what's it going to become? Negative, good. Subtracted by 1,434.1 is equal to, this negative side stays. So we have negative 1,249.14 cos C. Okay? We're going to evaluate these two numbers. I'm just going to do it on the calculator for the sake of time. 1,697.44 subtract 1,434.1. So 263.34 is equal to negative 1,000. There we go. Okay. So again, the whole goal of this is we're trying to isolate this C. We're going to get it by itself. So this says negative 1,249.14 multiplied by this. So to get cos C by itself, I need to divide both sides of the equation by the number it's supposed to be multiplied by, which is negative 1,249.14. We're going to divide both sides of the equation by this number. Okay. These numbers will cancel each other out, so we'll just be left with cos C on the right side. On the left side, divided by 1, 2. We're going to get negative 0.2108. Okay, we went to 4 decimal places. That way we're going to stay very accurate. Now, there's still one more step in order to solve this. I know what cos C is, but I don't know what the angle is. I need to move cos to the other side of the equation. Okay? When I move cos over, what is it going to become? When we push shift on our calculator, what does cos look like? Cos inverse. Good. So when we move it to the other side, we end up with our cos inverse. Negative 0.2108 equals C. Okay. So cos inverse of negative 0.21. Anyone following along on their calculator know what we got? Okay, the angle, we're going to round it, is approximately 102 degrees. So we figured out that the angle Z, is 102 degrees. So we're going to go back to that other page that we were just on. Okay, so this angle Z here, that angle is 102 degrees. Now the question asked us, determine the measure of the angle. So we did the first part, and show your work. Is the angle obtuse? Is this an obtuse angle? Yes, any angle greater than 90 is obtuse. So angle Z is equal to 102 degrees. And yes, is obtuse. Okay, part C of this question here. Okay, 16C says determine the measure of the other angles. Can you use sine law? So this is important. This is a two-part question again. We need to determine the other angles. We have one of them, which is 102. They're asking us if we can use sine law. Does anyone know if we can, or what the rule is to use sine law? I think so too. The reason we can use sine law is because we have a complete ratio. And what I mean by that, for a complete ratio, we need to have the measurement of an opposite side and an opposite angle, which we now have. So because we have that, let's set up our sine law with our ABC again, okay? Oh, wrong one. So sine angle A, we don't know what it is. So we're going to call it sine A divided by side A is 19.1 is equal to sine angle B. Again, we don't know what that is. Side B is 32.7. And finally, sine C, which is 102, divided by 41.2. So because we have this complete ratio here, we can use our sine law. Okay? I'm going to choose one of these angles. Let's say we're going to solve for sine B. Okay? So that means I don't need that part of the equation. So we're going to go to the next page and we're going to set this up again and solve for it. Alright, so we've set this up on the next page. The goal here is to get sine B by itself. So in other words, the top of this fraction. So what I'm going to do to get the top of this fraction by itself is I'm going to move the denominator or the bottom of the fraction to the other side of the equation. Now because this says divided by, when I move it over, what's going to happen? What operation do I need to use? Multiplied. Good. So we're going to be left on the left side with just sine B is equal to sine 102 divided by 41.2. And then when we move that over, we have multiplied by 32.7. Okay? So we're going to put that into our calculator. $102, is that sine? Sine divided by 41.2 times 32.7. I cannot read that number, but I'm going to do it also on my calculator here. Sine 102 divided by 41.2. Is it 07763? Oh, good. All right, so we got the right one. I typed it in properly. 0.7763. Okay. So, can that be the measure of an angle? It's pretty unlikely we have a measurement of an angle less than 1 degree. What have I forgotten to do? What do I still need to do? Yes, I need to move sine to the other side. So that way B is completely isolated. When sine gets moved to the other side, we're using sine inverse. So sine inverse of that decimal number, 0.7763. So we get sine inverse of that answer, 50.9. So angle B is 50.9, which means we're going to say it's approximately 51 degrees. Okay? So
you might be
okay.
wrong.
50 degrees was our angle B. So that means this angle here, was 51 degrees. So I've discovered what two of the angles are. Angle B is 51 degrees. Angle C is 102. What is a quick way to find out the other angle? That's right. Triangle's going to add up to 180 degrees. Okay? So we're going to take 180, and we're going to subtract the two angles we already have, which are 102. That's going to give me 78. I subtract 51 from that. It's going to give me 27. So the third angle, which is angle A, is equal to 37 degrees. Okay, question 11. Question 11 says, angle C is an angle in a triangle with cos C is equal to 0.11. Sorry, that showed up. Determine the measure of angle C. So they've given us almost all the information we needed. There was just one last step. How would I solve this for an angle? How would I solve for angle C? How do I isolate C? Told me how to do it before, David. What do I got to do here? That's right. I need to move cos to the other side of the equation so that C is by itself. So we get C is equal to cos inverse of that number So cos inverse of 0.11, 83. So that means angle C is 83 degrees. Okay, question 14. Question 14 is a word problem. It says a pilot's instruments tell her that she is 2,354 meters from a landing strip. The angle of depression to the edge of the landing strip is 32 degrees. So here's our landing strip. Here's the pilot. This is the angle of depression. This is our distance. The very first question is asking us for the altitude. They've already labeled it as A for us. Now this is a right angle triangle, so what does that mean? What ratios or formulas can we use? Right angle triangle means that we can use these ratios here. The primary trig ratio, SOHCAHTOA. Okay? So, I'm looking for the opposite of the angle of depression, and I have the hypotenuse. So, that means, which ratio am I working with that has opposite and hypotenuse? Good, sine. Sine 32 is equal to the opposite, which is our A, and the hypotenuse is 2,354. Okay? We're going to do this on the next page so that we have room. So here's our question. We need to isolate A once again. So I'm going to move 2,354 to the other side. When I do that, I get 2,354 multiplied by sine 32. That's going to give us our A, the altitude of our pilot. So 32 sine times 2,354. Sine 32 times 2,354. 1,247. So the altitude of our pilot is 1,247.4. We're just going to round it to a whole number. 47 meters above the ground. Okay? So we know that this side of the triangle is now 1,247. That's our answer to the first one. A, 1, 2, 4, 7. Okay? B says determine the horizontal distance to the landing strip. So in other words, what they mean is how far away horizontally is she to this landing strip. Again, it's a right angle triangle, so I can use one of the trig ratios. And in fact, I could use tangent, opposite, over adjacent, or I can use cosine because I have hypotenuse and looking for the adjacent. There's one other formula I could use to solve this. Anyone know? I have two sides of a right angle triangle. Pythagorean, that's right. We can use Pythagorean's theorem. I'm going to use that in this one just so you guys have an example of it. So, the hypotenuse of this triangle is 2,354. So in other words, that's our c squared. 2,354 squared is equal to 1,247 squared plus b squared. We're going to put that on the other page also. 2,354 squared, 1,247 squared, plus b squared. We need to get b by itself. We're trying to isolate for the horizontal distance. So I'm going to move the 1,247 squared to the other side. 2,354 squared. It will become subtract 1,247 squared is equal to b squared. We're going to square both those numbers. So the first one we get 5,541,316. Subtract 1,247 squared. 1,555,009. Well, I wrote that really funny, eh? Let's fix this up a little. We're going to subtract those two very large numbers. So 5,541,316 subtract 1,555,009 is equal to 3,986,307 is equal to b squared. How do I get b by itself? What do I need to do to both sides of this equation? That's right. So we need to square root both these to figure out what our b is. So the horizontal distance, 1,996.5. 1,996.5 meters. Okay? We can round up if we like, or you can leave it like it is. So we go back. I'm going to leave it like it is because we're almost halfway. 1,996.5 meters is the horizontal distance. So we've solved both A and B. So there is a lake 600 meters beyond the edge of the landing strip. So what that means for us, we'll use this. There is some lake 600 meters away. Okay, that's where the lake is going to start. So it's right there. Could be Lake Ontario. That distance is 600 meters. Okay, the pilot is still here. So we have to create a new triangle. This is how far away the lake is. Here's the horizontal distance. We need to know the angle of depression to this lake. So we had to create a new triangle here. While creating that new triangle, I actually already have several of the measurements. First of all, how high is the pilot into the air? The pilot is 1,247 meters already in the air. The height of the triangle is the exact same as the other triangle we're using. The pilot hasn't gone up or down from this point. Okay? The only one that's a little different is the horizontal distance. Now we knew the horizontal distance from here to here was 1,996. We've now added 600 to that number. So the new horizontal distance is going to be 1,996.5 plus 600, which is going to give us 2,596.5. We'll just leave it at that, okay? Meters. So in other words, we're going to just quickly create a small sketch of our new triangle. Okay, this is not to scale or anything. But we know the height is 1247. The horizontal distance is 2596. They said they want the angle of depression. The angle of depression is the horizontal distance, and then a line heading down from there. So we're looking for, we'll call it angle X here, okay? I have, according to that angle, I have the opposite side and the adjacent side. So which ratio would I be using in this question? Tangent, that's right. So we have tan X is equal to opposite, which is 1247, divided by adjacent, which is 2596. Tangent X is equal to, we'll divide those numbers, 1247 divide 2596, 0.4803. How do I get tan to the other side? What does it become? Inverse. So X is equal to tan inverse of that number, 0.4803. X, the angle of depression, is equal to 25.26. So the new angle of depression, 25.26 degrees. That angle is less than the original angle. Does that make sense? Is this a smaller angle than the other one we started with? Yes. Okay, this is a smaller angle than the old triangle we had, so that makes sense. We have an angle that is smaller than the 32 degrees. Our new angle is 25.6 degrees. Okay, question number 1 we're going to take up. Question 1 says a surveyor takes the measurements of a cliff using a laser rangefinder. He measures 31.8 meters to the top of the cliff and an angle of elevation of 61. What is the height of the cliff? They've given us a diagram. Hypotenuse, angle to the height of the cliff. We're looking for that side of the cliff, the actual height of this cliff. So, according to this angle, we have the opposite. We're looking for the opposite, and we have the adjacent. What ratio do I use because it's a right angle triangle? Anyone? We use our sine ratio. So sine 61 is equal to the opposite over the hypotenuse, which is 31.8. We need to get the x by itself. So when we move 31.8 to the other side, it becomes multiplied by sine 61 is equal to x. And when we equate those two, 61 sine times 31.8. So sine 61 times 31.8, 27.81 meters. So according to that, we're looking for answer D in this multiple choice. Answer D is the height of this cliff.